my name's Pichon. I work for the OnGo Alliance, and good talk to figure out what that is. I'll explain what that is. Building a lot on what Mr. Nagy talked about a couple of months ago now, he was talking about using private LTE in airports and things. This is the underlying technology that enables some of those use cases. So I'm going to talk about who we are, who the OnGo Alliance is, what the technology is, and sort of walk you through the basics of what one of these networks is, how it works, why it's of any use or interest to you, and then look at some like use cases of where places you can use this technology, where it could fit. And then go through the process, some of the highlights of how you deploy one of these networks. I figured most of you guys are, I heard a mechanical. How many of you guys are in wireless? All right. So, all right, we have a couple. All right. Okay. So, all right. So I will keep the discussion of VBs and things to a minimum because I live in that world, but try and stay away from that. Look at sort of what this means, the big picture stuff. There's CBRS is the term Citizens Broadband Radio Service, which is an unfortunate name. This is the name that was given to it by the FCC. Everybody thinks you mean CB radios. No, it's something else. This is CBRS is a new band that has been opened up for use for all sorts of purposes for general use spectrum that used to be allocated to primarily Department of Defense. So there's two kinds of spectrum in this world, right? There's licensed and unlicensed. And licensed is FM radios, whatever, cell phones and things. And unlicensed is stuff like Wi-Fi, where you just can go and use it. Well, the CBRS is a new concept that is it's dynamically allocated spectrum. It's a new type of spectrum. And this is the first use of this idea of dynamic sharing. And it comes out of initially the Department of Defense. They own lots of spectrum in various places, and they don't use it very efficiently. And so they kind of came up and said, you know what, maybe we'd be willing to share some of the spectrum we have allocated. And they worked with the NTIA, which is a government agency that handles spectrum allocations. It's part of the Department of Commerce. And then they went to the FCC, and they all worked out what they were going to do. And so they defined the system requirements, what they wanted this CBRS system to be. And then they partnered with a group called the Wireless Innovation Forum, the WIN Forum. And they said, okay, let's figure out the technical specs. How are you going to actually make this system work? And they're responsible for making the system work. And so 3GPP is what defines how cell phones work, the increasingly inaptly named Third Generation Partnership Project, and they define the LTE specs. And then there is finally the OnGo Alliance, who I work for. They are an industry org that's devoted to supporting 3GPP networks in this new spectrum. So how do you get an LTE or a 5G network to work in this new spectrum? So these are the players, in case you really want to know. And the big one is obviously the FCC, WIN Forum are the other big guys in charge, and then there's all the other folks that are involved, like our alliance. So what is CBRS? How is the system architected? Well, the basic idea is that there is access to this spectrum is coordinated by something called a spectrum access system, or a SAS. These are actually run by private entities. There's a couple of them, a couple of different companies that administer these SASs, and their job is to coordinate access to this spectrum. There are environmental sensors that are detected around the country to look for incumbents, and then there are the actual radios, which are called CBSDs. And the incumbents, when you're talking about the CBRS band, the incumbents are of two types. These people that were there before, the wireless internet service providers, WISPs. These guys mostly provide internet service out in country rural areas. And the other big one and the truly big ones are aircraft carriers. They have some automatic landing systems and radars that they use that sit inside the CBRS band.
Well, so you said aircraft carrier.
Yes.
I think you meant commercial aircraft.
No, I mean aircraft carriers. I mean
Top Gun.
Enterprise.
Oh,
Like a
really?
boat. I really mean aircraft carriers.
There are not many of those in Texas.
There are some there. Oddly enough, there's a big naval air station in Memphis, of all places. Why the Navy has a big presence in Memphis is kind of a bit odd. But these are the incumbents, and really, the aircraft carriers is It's, yeah, primarily. They're planning ahead. The aircraft carriers, it's their automatic landing systems, their coordination for the pilot approach.
Is like Levon right now.
Yeah, we keep talking, you can see the videos of the sharks up there.
We could race the Trinity.
It would, I don't know if you can get it big enough to send an aircraft carrier up here. But the idea is that these incumbents are out there. Some of them we know where they are, like there's some fixed satellite terminals that we know where they are. We know where the WISPs are. The aircraft carriers, they tend to move around a lot, but you can be pretty confident they're not going to be in Oklahoma. What we do have, what was part of the system was called the environmental sensing capability. They put a bunch of antennas in various places to listen for these incumbents. And the idea is if the sensors say, hey, I hear one of these incumbents, they notify the spectrum access system, and then it tells all the radios out there that might interfere with this system to shut up, to turn off, move to a different frequency, or reduce their volume, to reduce their power level. And so that's what the SASs do. They coordinate with these environmental sensors, and then they tell the radios in the CBRS band to move out of the way so you don't interfere. And so that's the basic idea of this dynamically shared spectrum. Traditional spectrum, to get access to, you have to buy a license, and you get those licenses from auction from the FCC. And how much do those cost? Billions of dollars. So the idea of the CBSD and the CBRS system is that we're going to have spectrum that is open, but still coordinated. And we're actually going to have a new licensing model as well that we use. So these are the bits we'll get here. I did the history, it's not very interesting. So the basic idea of it is that there are tiers of access into this band. It's 150 megahertz sitting up at 3.5 GHz, which doesn't really sound like a lot if you're not being into the wireless industry. 150 megahertz is an insane amount of spectrum. The national carriers, like nationwide, after spending hundreds of billions of dollars, might have like 20 megahertz nationwide in most across the country. So this is a big chunk of spectrum, which is worth a lot of potential money. And so what they did is they said, okay, the tier ones are incumbents. They're going to get preferred access into this band. They're the top priority. And these are the DoD radars. There's the WISP. There's some satellite terminals as too. And then they auctioned off what they called priority access licenses, PALs. These were auctioned off, I think, about 2 years ago. These were auctioned off under different terms than usually happens with the FCC. It was done on a per county basis, and you could grab access to up to 4 channels. The band itself is divided into 15 channels of 10 megahertz each. An individual PAL person could buy access to those four of those channels. A total of 7 were auctioned, and the other 8 channels are open for the lowest priority, the general authorized access, the GAA users. And anybody else that wants to use the spectrum, if you want to use it, you can either get a PAL, which that auction was a couple of years ago, so you can't get one now. And it was like a $5 billion auction, so it worked pretty well. If you want, though, you can come in as a generally authorized user, and you can go to the SAS and say, hey, I would like to turn on a radio. I want 30 megahertz. This is where I am. And the SAS will tell you, okay, yeah, I'm going to give you, here's the frequency channel you can use. And check in with me periodically. I'll let you know if there's an incumbent that you need to shut up for, to get out of the way of. And so these are the three tiers. Incumbents.
So on tier 2 for the PALs, are you seeing any behavior where some of those PALs are actually sub-licensing?
Yes.
Okay.
The sub-licensing is allowed. There has been an administrative issue with the FCC. Never had to deal with getting access to a spectrum license. There's like this 500-page form that you would rather pull out your own teeth than try and fill out. They've been doing a shorter form that's like 2 pages to handle being a PAL sub-license. And that's been the biggest headache. But I think that got deployed a couple of months ago, so you can fully sub-license the PALs.
As a follow-on to his, in the GAA, if the SAS administrator says, well, you have to shut up, do they give you another set of channels you can use at that time?
Yes, the SASs will, if they can, tell you that, okay, I need to allocate, say, the top 50 megahertz for an incumbent aircraft carrier showing up in Kansas. You need to clear out that 50 megahertz. It can tell the PALs and the GA users, okay, move to another channel. And it can say,
And is the infrastructure there to do this in real time
Yes.
already?
it's real time and it's done right now. The SASs, it is done actively. It is currently done. The only issue right now with the SASs, there's multiple ones of them. They coordinate every 24 hours to get everything in sync. But if an incumbent shows up, the SASs immediately form all the radios, which we call CBSDs and CBRS alliances, go to get out of the way. And it may be actually what you more often see is reduce your power level, move to a different channel, and they'll cut your channel allocation. They say you had 30 megahertz, please go down to 10 megahertz so everybody can play together. There's a couple other interesting things that come with the PALs. The PALs are only allowed to get 4 of the channels, but if they're not using them, they're open to everyone. So the PAL auction, even though those say here, I think all 7 channels were auctioned off in Dallas County, if nobody's using those PALs, it's allocated to GAA users. So you actually have to be using the PAL to get that protection. If you don't have a PAL, you just have GA access, and it's kind of a free-for-all there. The PALs have protection against interference. They're actually protected. The GAA users are told don't use these channels, and they actually do a lot of signal monitoring and processing and simulation to determine. They have propagation models will say, okay, you're so many miles away from the edge of the PAL, therefore, okay, you'll have to be below this power level and you'll be fine. And so they have propagation models that are included into the SASs to try and protect both the incumbents and the PALs. And right now, one of the things that's going on right now within the OnGo Alliance is defining a coexistence manager for the GAA users so that you can coordinate between the GAA users so you don't interfere with each other. We'll talk a little bit more about it.
Is it custom the GAA?
No, it does not cost you anything. You do have to have a contract with the SAS, and they do have different commercial models. Google does their usual thing. It's free. They bill you another way. But the different ones have different models. Some will be like per CBSD or per user, but it's pretty low.
It's Federated, CommScope, and Sony, and Broad.
And there's a couple of additional SASs that are going to be coming online here.
Showcase was standing up for that too, right?
Yeah, I think that they're going to be in the way too, isn't it? Yeah. I actually the list, but yeah, it's CommScope, Federated, Google, and Sony. But there was another one they shut down, right? NDocs is the other one.
I thought MDOT shut down.
Yeah, NDocs I think is the one that's shutting down. There's there's different terms, but basically, yeah, you have to pay, but you get access.
And how do you differ from the SAS though? You said you're part of what the OnGo does is coordinate to make sure you don't get in each other's way.
Right.
But that's actually the SAS. Isn't that the SAS's function to sit there and say is okay, you can transmit at X power in these bands, and
right. Formally, that is what the SASs are required to do for the PACs. For the GAAs, there is no formal requirement for protection or coordination from the FCC. We are working on defining some mechanisms to help support that and add that capability as an additional feature of the SAS. But right now, all the SASs do with the GAA guys is say, okay, based off where you are, here's the power level, maximum power level, and these are the channels you can use. And they can choose to use whichever channels they want. And if there's another GAA user right next to you, they get told the same thing. These are the channels, these are the power levels. And so you can end up getting interference between different GAA. And we're working on fixing that problem right now. The problem is actually much less severe than people tend to think, because there are 2 limitations that happen on the CBSDs, the transmitter side. Go back here. Let's see. If we go to the CBSDs, they have 2 different categories. For indoor deployments, it's less than 1 watt per channel. If it's outdoors, it's less than 10 watts. And the propagation models actually include whether or not you're indoor or outdoor in your antenna pattern. And so if you're indoors, you're probably not going to have a lot of interference from other GA users, or if you're going to have, or from the PAL guys. you're typically you're gonna run into interference issues more likely if you're outdoors. But again, that's a feature that we're working on adding, and as you can imagine, it is not a trivial problem to solve.
And CAFD requires professional installation.
Yes. I'll get there in a bit. Okay.
Yeah, by the way, from a Wi-Fi 6E standpoint, you know, when you're actually going to be using the 6 gigahertz spectrum in Wi-Fi 6E, that's also lightly licensed, and that for outdoor use, you're going to need to also have the SAS for that.
And I'll talk towards the end also.
That's not on yours.
This is the first attempt at this sort of dynamic modeling or the dynamic spectrum allocation. I think it's going to end up, there's already talk about adding additional spectrum to this management scheme. So we'll see how that plays out. And this is US only, and there's going to be a bunch of other stuff coming too. And I do want to state too, this is for real. This is not some future looking stuff. This is already deployed. There's something on the order of 300,000 CBSDs already out there. These are active networks that are in active use. I think the full commercial service was in 2020, early 2020, and our timing coincided quite well with COVID, and everybody's plans got thrown a who. Everybody was thinking we were primarily going to be indoor deployments initially, but that's turned out not to be the case. Most of the deployments have been outdoor deployments. A lot of school districts, right? A lot of school districts have been used to provide emergency access, basically, as everybody's done virtual remote. So those are the tiers. The spectrum, again, it's 3550 to 3700. It's 15 10 megahertz channels. The PALs are actually restricted to the lower 10. The upper 5 are primarily GAA, but there's more incumbents that exist in the upper 50 megahertz. So you're somewhat more likely to run into coordination problems. So that's the basics of CBRS, this dynamic spectrum allocation. There's SASs that coordinate and allocate and give you access to the band. And then there's an OnGo network, and we are simply networks that are using LTE or 5G and R to provide your network in that spectrum. We actually have designed our whole system, all of our specifications, et cetera, don't touch the air interface between the phone and the base station. So any off-the-shelf phone you get that supports this band can work within an OnGo network. You're not having to buy special equipment or special phones in order for this to work. It's sports band 48, or as 3GP calls it for 5G, it's band N48. They had put an N on everything in 5G. It's band N48. But if a device supports it, your phone can work on one of these networks. What we have defined within the OnGo Alliance is some of the back-end stuff. How does the eNode B, the base station, talk to the CBSDs? How do the CBSDs talk to the SASs? And how do they interact with all the requirements that came out of the FCC? And it's really pretty straightforward. The base stations are constantly talking to the SASs, and the SASs will tell them to shut off, and they have to shut down their power. If they're told to reduce their power or turn off. But it's an LTE network, and assuming folks have a vague idea how cell phone networks work, you have a eNode B or a GNode B. Those are the base stations, the towers that are your fixed access points. Then you have your user devices, your phones. 3GPP likes to call them UEs. CBRS requirements talk about them as EUDs because nobody can use the same acronyms. It would be too easy that way. Right, so they're the phones, the UEs, are the mobile devices. And then for a 3GPP network, there is an extra element. It's the core network, the core network infrastructure that coordinates the CBSDs. In LTE, it's called an evolved packet core. In 5G, it's called a 5G core network. And this handles like the data routing, the mobility, the authentication, billing, all that stuff. All right, so any device works that it supports band 48 will work in CBRS. It's really quite handy. They're working on it. So for people that are looking to solve various communications problems, what does this mean? The short answer of this is that what OnGo means is you can now deploy an LTE or a 5G network when it wasn't really practical before. Previously, you had to have a spectrum license from the FCC, and those cost hundreds of millions, if not billions of dollars. Now you can deploy a private LTE or 3GPP network and don't have that huge licensing cost up front. So it becomes much more practical to deploy one of these. You can put one in your house, you can do one in your office. And it really was not practical before because you couldn't get access to spectrum. So small private networks you can now do in a commercially viable fashion. And this is like their status report. This is from February. Over 200,000 CBSDs active, 17,000 PALs were auctioned off, and these things are active and running right now. So that's the basics of what we're talking about.
So is this, in fact, a commercial competitor to just do a Wi-Fi router?
Yep.
Okay. Okay.
So help me understand OnGo. What stops me from just going to Nokia, buying an NDAC, getting a license with SaaS, with a SaaS provider, and running? How does OnGo fit into that?
Don't fit in at all. We'll do that, not a problem. All we've done, what we have done, we're an industry organization trying to promote this, provide some additional support services, and define some of the interfaces and standards. If you want to deploy one of these networks, yeah, that's what you do. You go call up Nokia, you go buy cells, whoever, and you set one up. And it's not that hard. There's some little twiddly bits that we'll get to that we help support do it. But we're trying to make this as absolutely that simple as possible.
And the reason I was asking questions is you said OnGo network in your previous slide, and it made it sound like you were a neutral host provider.
No,
or something like that. And I was going, what? So that was what.
Yeah, no. When I say an OnGo network, we just mean an LTE or 5G network that's in the CBRS band. So we as an alliance don't actually operate or function in it. So we're just helping people deploy. So LTE, 5G, anybody when you was here before did a lot of talking about LTE and 5G, right? People want to be quick high level on what 5G is and why it's better than LTE. Anybody?
Yes.
Yeah, you want to hear it?
I
Okay, it's much better. Everyone knows LTE is 4G and 5G is 5G. It is one extra G, so it's better.
Thank
That's all you need to know. So that's the difference. So LTE, if you're really doing it, we're talking to the frequency division multiplex technology. It's TDD, time division duplexing, or frequency division duplexing. In an OnGo network in the CBRS band, it's allocated for time division duplexing. So the phones and the base stations are on the same channel. They just alternate and coordinate when which side is talking. Most of the networks these days are actually TDD, so their different frequency bands are allocated for TDD or FDD. Everybody knows LTE because you've got the devices. 5G is really just an evolution of LTE. There is nothing really radically different in terms of its capabilities. There's some really cool features, but it is not a radically different technology. He's probably going to yell at me as I go back.
No, it's just release 15 of 3G.
Yeah, and it really is.
17, right?
Yeah, 17 just 16 dropped, 17 is about to drop. And they're just blocked. 18 they're on here anyway.
Yeah.
So 18 is in study, 17 is about to go out.
About to go off, yeah.
16 is hot.
Yeah, 16 just dropped 3 weeks.
Right, and the basics of LTE are that it's improved spectral efficiency. Not a huge difference, but it's slightly better, on the order of like 10% better. So in terms of what LTE can do versus 5G, total bandwidth capacity is about 10% better. However, there's another bit of it. We'll have to get to in a bit too. There's also reduced latency. The round trip latency on the network is much lower than it was in LTE. The goal is to get to 1 millisecond latency, which is crazy aggressive for a terrestrial network over those kind of ranges, but that's what they're going for. There's also a lot of additional flexibility in how you configure the networks, how like the TDD allocation can be changed on the fly. And there's a lot of incorporation of things like virtualization, network slicing. And it's really cool, depending on who you talk to, it's going to be the best thing ever, or no one's ever going to do it. But the basic idea of network slicing is you can have multiple virtual networks on the same hardware. So you could have a private and a public network all on the same hardware. It's just their virtual networks. There's a lot of improvement to the security. The security model is heavily updated for 5G. As noted, Wi-Fi has done their first update to their security in like 20 years in Wi-Fi 6. LTE, 5G, the 3GPP has put a lot of effort into the security architecture of this. So one of the nice things about an OnGo network, you pretty much get carrier-grade security out of the box by default. So you're not having to do quite as much in terms of adding capabilities for the security side of it. The other big thing is the new frequency range, and this is when everyone's, if you see all the ads, like 5G is awesome. It's going to take all the carbs out of your pasta. It's going to toast your bread while you slice it. It's going to be awesome. And it's going to do these multi-gigabit capacities. And that's really a function of this new frequency range, the millimeter wave range at like 24 gigahertz and up. There's just been a huge chunk of allocation of spectrum. So a 5G network can get to much higher bandwidths because they can use these channels. There is a problem with these channels though. What is the propagation of radio waves at 24 gig?
100 meters.
Sure, the range is very low, which is actually, from a network planning perspective, actually a good thing to see how much reduce interference. But it does not. You're not going to be doing these big outdoor 70 gig multi-mile, multi-gigabit connections over 5G. It's not magic. They just allocated a bunch of spectrum way up there, and you can do short throws at very high bit rate. Now, this doesn't apply, though. This whole frequency range doesn't really apply for a 5G network in the CBRS band because we're in the mid-band.
So just because I have to deal with this confusion by what you just said, on an ongoing basis, 5G is not only millimeter wave, that's just where AT&T and Verizon got spectrum to do this.
Yes.
T-Mobile runs a mid-band implementation. We're going to talk about CBRS with 5G. It's going to have a mid-band implementation, and that being changes, and it gets people confused all the time.
There's a lot of people that think that 5G, in addition to giving you polio or whatever the latest conspiracy is, they think it is purely this upper band. And it's not.
So if you ever see those T-Mobile commercials, Verizon commercials where, T-Mobile says they have the longest 5G network, and Verizon will say, we're T-Mobile, their 5G is so slow. Well, what they're doing is they're comparing the 5G on T-Mobile's 600 megahertz spectrum, which is 5G in low band, versus the 5G on the millimeter wave of AT&T. If you notice, they do those commercials outdoors as well, because you really can't, it won't penetrate the glass. The millimeter wave. But they're both 5G. Just what goes to band allocation is the propagation of the frequencies, otherwise known as physics.
It's basic physics. It has 24 gig humidifier. Its propagation is not nearly as clean as it is with most people we're used to with cell phone stock network. Okay. But that is only one part of 5G. Oddly enough, because of the marketing and because of AT&T and all this, everybody thinks this is what 5G is, and it really is. So that's just the high bit. Now, if you're looking to deploy a network and you're trying to provide wireless data services, first question people should be asking.
I want to correct you. AT&T's not marketing. Right.
Yeah,
It's
yeah.
Verizon.
It's Verizon.
and T-Mobile.
I have to be equal, since I work for an industry organization that has multiple carriers as members, I have to be equitable with my scoring. So you're right.
Actually, AT&T has done the most, they've done the nicest job of it.
Yeah, but yeah, Verizon's
Now,
has
they
really pushed the.
They did put the 5G on their phone, which.
Yeah, that was kind of irritating. But that's the basics. 5G is really, it is an evolution of LTE. This new band has allowed you to do these high bandwidths, but the really cool stuff, frankly, in 5G is not the high bandwidth, because frankly, there's only so many gigabits your phone needs, right? There's just that they can't consume the data. So they're talking about all these use cases that for most people, LTE is perfectly fine. Right, so if you're deploying a network, the question always comes, why don't I just deploy Wi-Fi? Well, everybody knows Wi-Fi. Wi-Fi is awesome. On a cost per bit basis, it's hard to beat Wi-Fi. We're using Wi-Fi right now. LTE, though, and 5G, these 3GPP techs have a couple of advantages. One is, and Wi-Fi 6 has added this, but it's a scheduled system. That is, the devices don't do listen before talk. They actually have to get coordination from the base station, say, hey, I need to talk to you. And they get scheduled for uplink and downlink. So these systems tend to perform much better under load. Everyone's used to Wi-Fi networks, like you said, at the DFW airport, where you have everybody's devices, and the Wi-Fi system just doesn't work. Well, the nice thing about an LTE system or 5G system is under load, They tend to work much, much better. They get consistent performance. They have hardware-based security, USIM, the SIM card. We have eSIM as well. So you have very nice encryption systems that are built in. You also have mobility baked into this from the beginning, both in terms of mobile devices and for 5G. I think their target is 500 kilometers an hour, which is probably more than you're going to need in a house or in an office building, but you just the mobility's there. There's reliable handovers that infrastructures are built in. And your coverage is going to be better per access point. At the same power levels, just in general, an LTE or a 5G system is going to have longer range, more coverage per access point compared to Wi-Fi. And of course, if you're able to deploy at higher power levels, if you're outdoors, you can get much further ranges out of a 5G or an LTE base station. There's the spectrum access aspect. Because it's coordinated, particularly if you're doing a PAL sub-license, you actually have protected access to the band. As opposed to Wi-Fi, which is really great. Wi-Fi 6 comes down. I've already deployed in my house. Nobody else has Wi-Fi 6. I have great signal to noise, and it's all my neighbors. Those jerks deploy Wi-Fi 6 themselves. The performance of my network goes down. But one of them has named their Wi-Fi point FBI land, which always makes me a little twitchy. The other thing that's baked into the 3GPP networks is quality of service. There's a lot of control and prioritization of data types, data stream types, and users that are baked into the 3GPP system. So you can prioritize things like video. You can optimize the capabilities of the devices based on what they're using. So you can get a lot of these capabilities built into the system. So in some cases, Wi-Fi is going to be the right choice. In other cases, CBRS or OnGo network is going to be a better choice. And really, it's not an either-or choice in most cases. You want to actually be looking to deploy both of these at once. You can have Wi-Fi, and you can also have an OnGo network in the same area. And if you do that, the performance of both networks improves. You put the data where it needs to go. Those system resources can be allocated better to where you need them. So often when we look at these deployments, we're seeing people deploying CBRS as well as their Wi-Fi network. And you can really see a real improvement in performance if you have both of these doing at once and you put the devices where they are best suited. In fact, there's one of my other clients I work with is a group called Multifire. Have you ever heard of Multifire? Okay. 2 people have heard of Multifire, right? Multifire is unlicensed LTE. They actually added a listen before talk on LTE, and you can deploy it on the same channel as Wi-Fi, and your overall capacity for both networks goes up when you do that. Because the way that the Wi-Fi is sort of best effort go, the fact that you can schedule and stuff on the LTE side ended up you get better improved performance if you do both. So again, it's not an either or. There are lots of various wireless communication technologies out there. This is just another one that has different characteristics. It's really good at some stuff. It's not so good at some other things. So it's another tool in your toolbox. When you want to use LTE versus something like Wi-Fi, it's when you have a high device density. That really is, I think, Peter, you mentioned last when we were talking about 5G. That is the coolest part about 5G. Is the device density per square kilometer is insane. It's really quite cool. You can get better performance out to your cell layers than you can with Wi-Fi. So those are the big reasons.
That's the difference between LTE and 5G is with LTE it's 2,200 current connections per square kilometer, and with 5G theoretically it's a million.
Yeah. It's crazy how many more devices. And so when you start talking about LTE and 5G, everybody starts talking about Internet of Things, of course, and that's going to be one of the really big key elements. The other interesting thing from a network architecture perspective is that the 3GPP has built-in interaction and interfaces with other networks, both in terms of security. So if you establish a secure connection, it can hand it off to another technology or accept authentication, credentialing from another network. They have various methods for doing this, handling non-3GPP networks. So you can establish a secure connection over Wi-Fi and transfer it over to your 5G network. You can hand off in and out of it very easily, which is really, really handy. All right, so when do you want to use OnGo? When is this the best solution for your problems, whatever they might happen to be? So the biggest one is if you have lots and lots of devices And if you need controlled low latency, if you need consistent latency, a 3GPP network is going to be much better than using a Wi-Fi type network. And for 5G specifically, the addition of a low latency, that's a critical aspect of your use case. That's when you really want to do 5G. But in the grand scheme of things, LTE for most use cases is going to solve your problem, and it's going to solve it well. The nicest thing about going to 5G is that there are multiple migration paths. The way they've defined the specifications, I'll get there. Yeah, here we go. They've defined multiple ways to migrate from LTE to 5G. So you can deploy both, or you can deploy an EPC, an LTE network, use the core network from an LTE system, add a 5G radio link, and then over time you can migrate your backend architecture to the 5G core network, and then you can shut down your LTE network. It's designed to migrate. There's all sorts of different models for doing it, and it's all baked in. So if you're trying to consider whether or not you want to do LTE or 5G, the answer is often do LTE now and prep to migrate to 5G in the future. And there's all sorts of ways to do it. Most of the networks right now.
Why would you do that if you are greenfield?
The greenfield, because 5G is more expensive right now, basically. And that's available.
I was going to say.
Yeah, you'll hear people get very upset when you say 5G is more expensive, and you'll get people get very upset when you don't say it costs 4 times as much. There's a lot of disagreement, but if you're on a greenfield line, at this point.
But you're doing like a low bandwidth device. What's the cost of the chipset something like that versus
LTE, my understanding, the chipsets right now have about a 50% margin over that, and it depends on the full capability. Blah 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 blah. But that's the number that I hear about.
They're both like $100, right?
Yeah, they're not ridiculously expensive. It's not as cheap as a Wi-Fi chip, of course. And this is one of the other big differences you'll hear people talk about 5G networks is non-standalone versus standalone. So when they deployed 5G initially, released 15 initial specs that came out of 3GPP, they didn't define the backend. All they defined was the air interface between the base station and the phone. And what you did is you used an LTE network as your control channel, and then if your device supported 5G, it would set up a secondary channel on a secondary air link. Most of the initial deployments of 5G are this non-standalone. You actually have an LTE network as your anchor. And then they released later on the full specification of standalone, where you have a full 5G core network and using the 5G in our air interface. So that's the basics. If you want the number breakdown, there's all sorts of numbers that you can look at. The big one, again, is the additional number of devices per square kilometer. This is baked into the control channel. It is nuts, the level of user density that they wanted to achieve. There's some other minor things. Their goal is to be 100 times more energy efficient. I don't think they're ever going to reach that. But in theory, 5G has got some features in it that make it a little less energy intensive on the handset side. However, if you're pumping a gigabit out of one of these devices, yeah, there's some thermal management issues showing up on some of the phones. But as a broad practical thing, the spectral efficiency is only about 10% better under LTE.
There are studies showing, I think, Telecom Italia basically ran a 40% energy improvement over an LTE implementation. I mean, so I'll buy your statement around 100 times is a push, but they are seeing some very real numbers.
They're seeing, I haven't seen that one, but they've gotten 40% reduction. Yeah, and also there's also the ongoing reduction of cost for operation. It's just going down. The protocol itself is designed to be. If they've gotten 40%, that's pretty impressive.
I mean, part of it is again how you measure things, and you start looking at this as energy consumption per megabit transmission. That's part of how they did that.
Yeah.
So then all of a sudden you start seeing these massive numbers start showing up.
Cool. I'd love to. I'll have to check that out. Mobility again, 500 kilometers an hour. But the goal, one of the goals with 5GS was to enable what they call ultra reliable, low latency communication. where their goal is to get 1 millisecond round trip latency on the network side, which is, again, crazy aggressive. It actually hasn't been deployed yet. I don't think in a commercial deployment that's ultra reliable, low latency, but that's one of the things they're trying to do. Let's see. So, and the big 5G use cases that everyone talks about, it's enhanced mobile broadband, the ultra reliable low latency communications, and then there's the Internet of Things. Those are the 3 big use cases that they've driven for in LTE. I've talked enough now about 5G. I could talk about security, but it gets really dull really fast. And you have to be a specialist to really understand some of this. The big difference, the cool thing that's happened in 5G is they have fully secured the air link now. You never actually send the identifiers with the phone in the clear. That's not done at all now, so it's much harder to do some of these spoofing man-in-the-middle attacks. And they've also changed the model of the basic security is that services can be deployed through the core network and with established trust relationships via the network to the user devices. And the security models have been updated and our systems have been updated to allow and better support things like Internet of Things, very low power devices, so that the security doesn't put as much of a computational burden on the devices. But it's really slick. We actually have a white paper that's coming out probably next week on security. If you are really interested in wireless communication security and are having trouble sleeping, what a great document to read. It's about 100 pages of all sorts of interesting acronyms. But as I mentioned, they've added integration into non-trusted and trusted non-3GPP networks. It's baked into the architecture, which if you're a security guy, this is kind of cool. If you're not who here does digital security much, just keep. All right, so we have a couple of people. All right. It's really cool. It's really complicated, and I'm not going to delve too much into that. The network slicing aspect, this is one of the other interesting parts of 5G, is the concept of network sharing. And there's a bunch of different ways you can do it within 5G. You can actually have a shared air interface, but completely separate core networks. You can have the core network component shared. You can have the core network completely run by one of the carriers, for example, and you have your own virtual network that uses radios on your site, but all the computational hardware and the core network is run by the carrier. There's all sorts of different flexibilities that have been added into this. And the other big thing is mobile edge computing. Multi-user edge computing, I think is formally the acronym. If you have services that you need low latency, you can push them out into the edge of your network. And it's designed so you can actually have the tower have the services deployed there rather than in the cloud per se. That's all right. So types of networks. I'll give this sort of technical. This is the big high level stuff. One of the things you can do is a private network where the users have their own devices with their own SIMs that are designed to give you access to your network. Pretty straightforward. It's a private network. You can do that with a single SIM. A lot of devices now are multi-SIM, so you can have a device that will connect to the public networks, the MNOs, and you can also have your private network. You can authorize users to use your private network. So this is the bring your own device model, and you can do that in the CBRS or an OnGo network quite easily. There is another model too called the neutral host network. Anyone here heard of the neutral host network? It's the same 2 people right there. The idea of a neutral host network is that you have a common hardware shared network infrastructure that appears seamless to the user like they're on their own operator's home network. So like a place like here, a hotel could set up a neutral host network. They could have their network infrastructure here, and from our perspective, your phone would look like it was on AT&T's network or Verizon's network. Right? It would appear completely seamlessly. We would call these neutral host networks. And you can also deploy these in OnGo or a CBRS network can deploy a neutral host. And there's a bunch of different ways to do it. There's the classic roaming model, right? Everybody knows how roaming works. You go straight if you're traveling internationally, your phone charges you $1 bazillion to even out. Nobody really knows how roaming works. That's true. Nobody really knows how roaming works. I'll freely admit it now. There's also what's called a MORAN system, a multi-operator radio access network. And this is, you've heard of DAS, a distributed antenna system. This is what like a lot of stadiums and things have in them, where they have antennas set up around their facility, and the different operators basically can use those antennas for their network. From the user's perspective, they don't see anything different. They look like they're on their home network, but the actual infrastructure is at the facility at that site. And so you can have a DAS system that has offering services for T-Mobile, AT&T, Verizon, whoever. And from the user perspective, it's their same network, but the towers, antennas, and the base stations themselves are shared.
Quick question with regard to the roaming, because originally in the CBRS spec, there was the roaming model where they had the 56 current connections.
Yes.
With that.
It died.
Okay.
Nobody built it.
That would be cool.
That would be cool, and I'll tell you, I can explain at great length because I helped write those specs and nobody built it. But it's basically, they actually looked on the Multi-Fire Alliance. They defined a form of a neutral host network that could handle like 50 some odd.
Is it like 58 or?
It was on the order of the 50s. It's a really cool technology, and in fact, I actually gave a talk about it yesterday morning. The problem is nobody's actually implemented the device because it requires you to make changes at the handset side to make it work, and that's just economically, that's just not going to happen.
And I want to back up one slide for a second on eSIM.
Mm-hmm.
Are there any active eSIM out there yet?
Yeah, there was one at the meeting that we had in St. Louis last 2 weeks ago. That they actually had less. How work? Can't remember the name of the company. But
I know, right?
they can't remember who it was, but they actually had it there. You can set up the QR code right there.
And you would actually in your phone have
Yep.
eSIM and then go between, and you book between the phone.
Yep. And so when you have dual SIMs, the 3GPP hasn't defined how you select which is the active SIM.
Right.
So each of the phone makers does it slightly differently. But you can do the eSIMs, and most of them, they're all built in now. Apple and Android both support it. You take a picture of the QR code and it allocates this automatically. It's really slick. So the neutral host, though, the one that's more common, the problem with the MORAN or DAS system is it takes a lot of spectrum. Every operator has to be on its own channel. With a MOCN system, a multi-operator core network, you can have shared infrastructure and a shared channel. So you could set up in this hotel, you could get 20 megahertz and be offering service to all the different carriers on a single channel. MOCN is, the nice thing about MOCN is you don't have to do anything at the phone side. The phones automatically support this. You just have to set up the connections between the carriers. And I would refrain from comments about carriers. They work well together. Yeah, it's an interesting challenge, but MOCN's actually widely deployed in Canada. There's a big MOCN network up in Canada right now. Anyway, so that's the other type. There's a limitation. You can only have 6 operators on a MOCN or a MORAN system. But that's how many carriers are there in the US? 3, 4. So it's not really a real problem. But you can deploy these networks, and from the user's perspective, it's really cool. They don't see that they're on some kind of test network. They don't have to set up new credentials. It just shows that they just have service, and they don't have to think about it. All right, voice. How do you deploy voice? Gonna get to that roaming question. Nobody knows how it works. You can deploy voice solutions over the top, right, over via an app. You can use carrier services. That's what the neutral host networks are for. You can also set up roaming agreements so that people can roam in and out of the public network to the private network. There's a big study going on right now with AT&T that they're looking at setting up the roaming agreements so you can set up a private network that you can roam in and out of seamlessly if you have access to it. And if you want to get your own phone numbers, you can do this. You have to be a member of the GSMA. They've got a whole bunch of standards you have to implement. It is a non-trivial thing to do. It would probably be easier to go to a service company like an APX, and they'll set that up for you rather than doing it yourself. But if you wanted to set up your own phone number for an OnGo network, it's doable if you want to. So I have 10 minutes. All right, so we're talking about, so network use cases. The Alliance itself, we try to talk about a couple of different verticals that we look at different places and ways you can deploy this. In general, Where do OnGo networks work best? They work best indoors because you're more likely to be able to get access to a lot more spectrum. If you're in a big facility where you own the territory, like a warehouse or a mall, and you have physical control, you're going to be able to get a lot more access to spectrum. And if you're outdoors, particularly in an urban area, you're going to have a difficult time getting a lot of access. But you can sub-license from the PALs, which if you really need to have access. If you're in a rural area, that's a really good place to do this. We're seeing a lot of studies right now happening in smart agriculture because they need long-range data connectivity. But for the carriers, they're not going to deploy a tower on a farm, but you can set up a CBSD and have coverage of a lot of acres. So you're seeing a lot of use of some pilot programs right now for using CBRS in farms, which is not something I expect. Most of the protection areas are on the coast, so if you're inland, it's better than being on the coast. Again, not many aircraft carriers in Kansas.
What are you seeing relative to uplink limitations, though? EUD, my experience with it is that the uplink limited, and especially if you start talking about on the farm, I'm just sort of questioning that. I mean, if I stick it up on a pole 20 feet up in the air, it works just great, but down in the dirt, literally, it's
so mostly the uplink capacity is mostly a function of the TDD configuration. The TDD configuration, the carriers are very downlink heavy.
Yes.
And so you can set up an OnGo network to be much more uplink heavy in terms of timing. And so you get better performance there.
But I'm still seeing range performance issues that are control the TDD configurations.
Yeah, so there's going to be range issues. I can't give you specific metrics on that, but we're seeing that people are deploying that are very uplink heavy. And being doing it successfully. So, I think
The function of your device is heavy low power and crappy low antennas, right?
No, I mean, I've got decent devices putting out 1 watt of power, so those do better. But it's noise limited basically while I'm sitting there. But I put external antennas on things, I put them outside. I don't deal with a 15 dB loss going through a window or a door or a wall. It's a different story, but I'm seeing serious limitations, and that's dealing with, whether it be cradle points, link devices, trying to think what else I've got in there. But I've played with a bunch of different ones. Don't even talk to me about that. So,
I want to do this.
I had a conversation with them yesterday.
But they're not having very good uplink performance.
It could be the device that they actually purchased from.
In theory, you're going to have somewhat reduced performance just because you're going to be a lower power level on the mobile side, but we can do much more TDD uplink heavy configuration.
But that doesn't get me out of the noise floor.
No, it does not get you.
So,
We can't fix that physics problem.
and that's kind of where I'm sort of sitting and I'm begging to try and find some way around beating that problem. So,
Yeah, on the mobile side, I haven't mentioned it here. On the CBSD side, there is a provision that kind of higher power levels on the EUV side as long as it's not moving. But if it's a moving device, we're circuling it out.
okay, we'll talk about it.
Yes.
Interesting.
No, I'm sorry. I'm very curious to find out what the problems are because most of our use cases are uplink heavy. People are having problems. We can look at to see if we can fix it. So just some of the use cases that we talk about are autonomous vehicles, manned vehicles, just keeping track of them because we have the mobility baked in. You can have these reliable connections that can make use of those vehicles a lot easier and a lot safer. Building automation systems, the internet, the classic Internet of Things play. Also, we're seeing a lot of video applications where people want to look at video. And we're seeing, depending on who you talk to, I've seen personally an LTE that was doing 4 HD video uploads on a single channel, and they were doing it quite well. There's argument whether or not you have to be able to 5G to do 6 or more, but you can do lots of video fairly easily. Point of sale systems, particularly in places like sports venues and things, point of sale systems, they're having problems with them because the Wi-Fi just is not good enough. Particularly when they have big crowds, so they want to have a secondary system are an alternative to Wi-Fi for the points of sale. Workflow, employee communications, safety, worker safety. There's a lot of concern about tracking, and that's one of the things 5G also improved slightly is the positioning stuff. Its accuracy of positioning now is with release 16, it's 3 meters horizontal difference. They're aiming to get 1 meter accuracy out in release 17. I think that's the addition they're doing there. So digital signage, I mean, I can go through a bazillion of these things. One of the other key ones, and talking about multi-tech, it's using OnGo as a backhaul, using an LTE or a 5G backhaul connection. So we see a lot of bridges that work with multiple different technologies that you use the OnGo link for your backhaul, where it's not practical to run a long cable out to whatever system you're at. So we're seeing a lot of this interest for wireless backhaul, particularly coming out of the oil and gas industry.
On the school districts too, right?
And the school districts as well, and that's what they're doing. That was one of their things is they were just, well, they had 150 megahertz that the FCC was getting people to use, so they would just send out access points, hotspots, and CBRS worked really, really well for that.
What's the use case in school districts?
Because well, the problem is when they closed all the schools down, and I don't know, anybody here have kids? I haven't got a fourth grader. Yeah, it was a lot of fun doing remote learning, and a lot of places just did not have the network infrastructure to handle the amount of capacity. So they ended up deploying, I think I actually did one up at McKinney Ryan where they started sending out just sending an access point.
So all of the ones in this area did it. So Dallas Independent School put out probably 40,000 hotspots. Garland ISD, Dallas ISD, Fort Worth ISD all have CBRS networks up and running, and that are in various stages of execution. So, and there's a general, if you don't have kids, you watch it, there's a learning gap. Just about any kid, middle school and up, a good chunk of their homework and their learning activities are done online. They're submitting homework online, they're doing any follow-up work. If you look at Khan Academy, all of that stuff basically starts, so if you start dealing with digital equity issues, that becomes an issue.
And that was the nice thing. The timing worked out really well. So only had this 150 bank. We had devices, so a lot of school districts they would send out the access points. And it's not just for kids that are remote learning. It's the day-to-day activity, and in lots of areas they just don't have data infrastructure.
So there's an organization, if you're interested, called Consortium of School Networks. They did a study, and they found that over 60% of the bandwidth consumption takes place after school, and that's going through the school system. So filtered, controlled, all the rest of it. And it's because of that versus during school hours. We can get into the numbers on it.
I just see them showing my daughters on the school, on data, we're trying to shut down. I was amazed that network survived. Because it was just, they went from,
It is startling, yeah.
it was like something, we need to do 50 simultaneous bidirectional feeds, and we need 2,000 inbound full video calls at once. It's like, that's a lot of capacity. So we do see a lot of these wireless backhauls. This is where we're actually seeing a lot of guys doing SCADA systems, industrial systems. It is a way to solve some of those problems and not make your security nightmares worse. And so you can go with an OnGo type deployment as a bridge across these services and for your backhaul. We also see some people doing failover networks. We of course have the transportation stuff. We have bunches of use cases and studies about doing it in offices for coverage. You can do other things, public venues, sports stadiums. This is a big one, both to provide services to the attendees, ticket holders, but also to provide services to folks that are in that are actually the sports teams or the entertainers. And yes, this is in fact the Allen School District. That's the Allen Stadium that I use. And it's great fun going to people with these industry standards groups and saying, well, we have a high school stadium, we can seat 15,000 people. Like, no, they can't. Yeah, they can. So it's the full stadiums are really good. We're also seeing all types of babies. Yeah, they won't fall down now. Yeah. And now all the school districts around them have there's the edifice complex of the sports stadium. So just an example of a real one is the Wells Fargo Center in Philly. They deployed this and augmented their existing DAS systems. And they set up a 4-channel, so 40 megahertz LTE system, and they were feeding 4 HD video streams to their Jumbotron. using the CBRS network and also putting in their point of sale systems on this. And the cool thing is their cameras were Samsung phones. They were just using Galaxy phones as the cameras for the Jumbotron feeds. And so you're seeing a lot of these getting deployed in type stadiums. Now, these are really great use cases, but they're only so many stadiums, but this is a real world example. Here's another one that I think is really cool that Rippling did. This is in a warehouse, 75,000 square feet, and they're having serious problems with Wi-Fi connectivity. And what's the solution when you have Wi-Fi connectivity problems?
Antennas.
Yeah, you put more antennas. And what does that not do? It doesn't solve the problem. Yeah, it makes it worse. You have more noise interference. You have problems with network selection. And so they were putting in these access points. And this is just to support mobile scan guns for the people working there. And they were putting in $80,000 in hardware and about 50 grand in cabling because each cable pole is expensive. And they said, well, can we provide something with OnGo? And so they deployed it with OnGo, and it was $20,000 as opposed to over $100,000 to provide the needed coverage because they just needed a few access points. The propagation of the signals was better just because where they were in the spectrum, and the performance out to the cell edge is much better. So even to provide amongst all of the shelving, they were able to get few away with a lot fewer access points, and they were able to have to pull much less cable.
And the channels are given too. Because on a Wi-Fi, you know, it's where you're allocating the channel to.
Yeah, you have to coordinate all that. And it's seamless for them. The scanners have seamless connectivity as they move around.
So that's the CapEx spend.
That's the CapEx spend. Yeah. And the OpEx spend is a lot lower than people think because they actually went with a core network as a service, the monthly subscription for the core network.
I will say that one of the more interesting tours to do is to do the Death Star at AT&T Stadium if you ever get the opportunity. I think they charge for it too. But if you have the right connections and get to go on all of the back office but the systems tour of AT&T Stadium, it's incredible.
The data requirements they
Yeah.
have are just insane. Just providing the infrastructure for handling the guests.
Yeah, well, because they took AT&T there when they were building the stadium and said, this is our telco room, but they're putting everybody there, right? Verizon, T-Mobile, and AT&T walked in and said, this will be fine. And now, no, this will be fine. We'll take all of this.
Yeah, I'll take
Just AT&T.
Just the data. I'll take that whole data. And yeah, if you go into these, if you go peel behind, just the amount of cabling they pull, the amount of data services.
Incredible.
And it's incredible. They're restricted in what services they can provide because the user density is so high, the data demands are so high, they can't offer services that they want to. And so they're desperate at the stadium venue just to be able to set up so people will order concessions from their phone in their hand. And that takes a tremendous amount of network infrastructure because you got so many users in such a small area. And never mind providing actual data services, teams and things for coaches and such. Because nobody listens in on any of that communication. No, sir. Sorry, I lived in Boston. We did that all the time.
I know the Eagles played you guys in 2004.
I only lived there for 4 years. I take no credit. All right, so how do you deploy one of these networks? I'm running late here. So how do you deploy this? It's really, I won't say it's easy. It's much like deploying any other network. There are a couple of extra bits you have to deal with. The first bit is, can I get access? Can I get access to channels, the spectrum? You check to see if you're in an exclusion zone, and you can check to see what your pals were in your area. These are all online. You can do a quick search. But this is the exclusion zones across the United States. The Puerto Rico exclusion zone is probably going away because they're shutting down Arecibo, which is a shame. But most of the exclusion zones are on the coast. There are a couple that are inland, and you can see some places where a couple of channels have been allocated. One up in McKinney, they're blocked up there because Raytheon, they have their big radar facility there. They don't like it when you interfere with their radar. But most of the country, it's pretty open. And again, even the places where it's restricted, it's down. You only have like 30 megahertz available rather than full ones.
So the exclusion zones are on the coast.
That's where they got most of the incumbents are Navy radars, and so then most of the Navy's radars are on the coast.
And the aircraft carrier.
And if you've anybody here work in defense much, Because this is one of the weirdest commercial specs I've ever seen in my life. It has a chapter in the WinForm spec that is called security, the OPSEC spec. And it is the weirdest thing to see in a telecom spec, how to make sure the enemy can't tell what you're doing. It's not something you normally see in like a 3GPP spec, but they actually have protocols where they randomly shut down channels along the coast so that somebody can't just monitor the CBSD traffic to figure out where our aircraft carriers are.
And I'm thinking that one dot there in Tennessee is very close to Oak Ridge.
No, I think Oak Ridge is over this way.
Oh,
I can't
yeah.
remember what this one is. There's a couple of whisper quiet zones for whatever reason.
Interesting, just in the middle of
Yeah, in the middle of nowhere.
Huh, okay.
What's in New Mexico?
Area 50.
Area 51,
Area
Wismar.
51, and Los Alamos.
Yeah, Wismar, White Sands, Missile Ranges out there. This, I think, this is Pendleton or 29 Palms. I can't remember. It's a weird thing because this interfaces with DoD, and I did my time in DoD as punishment for my various sins. And you get these weird things where you'll get these labs calling and saying, I'm Office of Naval Research. Why can't I set up a radar here? Set up a CBRS network, because you have a radar on top of your building, and you get upset if you turn one of these on. It's kind of this weird interface. The exclusion zones, that's the exclusion zone. This is the high-level summary of the auctions. The dark color is where all 7 channels were sold off. And the lighter colors where it's only a couple. Pretty much every place except South Dakota, that's the only place that there wasn't a sold PAL license, probably because there's nobody in that part of South Dakota. But you can see, oddly enough, Louisiana is really well bought out. And if you break it apart, you can go online. I had the link before. If you go online, you can sort of see, where TVA bought a couple of channels. But they used a bunch of shell companies to hide who it was. They didn't say, so they're not bought under TVA. Everyone's like, why is there this weird blob or something reserved us? Anyway, so they're all over the place. Those are the PAL auctions. In general, outdoors is more difficult than indoors. But if you control the real estate and you don't let anybody else build towers on your property, you can get access to most of the channels, which is the thing that DFW Airport's doing. Nobody's going to set up a base station inside their area, so they get basically all 150 megahertz or beggars. And of course, you can always try and sell lines.
Do what?
The nuance to the FCC regulation.
You can, if you own the dirt, then you don't. Then you own you basically end up owning the airwaves too. And the PALs, even if there's a PAL in your county, if they're not using it, they don't get protected. And if you're outside of the geographic area that the PAL is using, you also don't have coverage.
You also can actually rent a PAL. Yeah. So if you have like a country fair, and like if you had like the state fair of Texas, you could actually buy PALs for 2 months if you rent them now longer.
And that's a pop-up deployment kind of things you can do pretty easily. There are multiple SAS administrators. They're approved by the FCC. The SASs went through extensive testing to make sure they all worked. There's a new second wave of SASs coming online. You can go to WinForm's website. They have the list. All of them have slightly different offerings in different commercial terms. Google's, I think, is the one that you don't have to pay. Sony, they do on like a per EUD, per handset basis. Some do it on a per base station basis. But it's as a service, whatever you want. Yeah, but with the Google one, I understand you get what you pay for it, but it's free. You just have to set up a contract with them. The other thing you have to do is a certified professional installer. The FCC requires, particularly for the big high power base stations, that they be installed by a certified professional installer, which everything about what I just said is wrong. They aren't actually installed by the CPIs. They're just registered by the CPIs. The register, they just tell the CBSD, they say the CBSD, they go to the SAS, and this is the GPS coordination, this is the kind of antenna. They don't actually have to install it. So it's kind of weird. I have to get a certified professional installer. Oh, that's going to be paid. No, they're just entering information in the database. There's a list of approved CPIs. There's like 5,000 of them right now.
City inspector then?
Yeah, and it's that simple. There's a bunch of training programs. The training's like 4 hours long. But so most of the time, instead of contracting with the CPI, you're planning to deploy one of these, become a CPI yourself. You don't have to worry about it. And for the smaller CBSDs, the category A, the low power indoor ones, they can have an auto register capability. They have GPS. They can connect if they can get their GPS location. So that's the CPI data. It's not that hard. You also have to get network identifiers. I'm not going to talk about this too much. You can go on our website. We have a webinar. I gave a webinar yesterday on this for a different word. But the 3GPP, they use public land mobile network IDs. Ever heard the PLMN ID word? It's the 6-digit code. It's been around for decades. It's run by the International Telecommunications Union. It works great if you're deploying a large network and there's only a few of you. The problem is well, that works when they're large. We have a bunch of large network operators, but only a few of them. Problem is with OnGo, we can have a bunch of small network operators and the system doesn't work. So what we've had to do is get a shared network ID. It's called the CBRS shared HNI. And we're lagging. So there's a bunch of identifiers that are used within the 3GP networks that are supposed to be globally unique. You can use the shared PLMN ID. There's one that's allocated to the CBRS band. It does cause a potential problem with network collisions. So you have to, if you want to use that shared PLMN ID, which you probably do, because getting one of your own is extraordinarily difficult. It is very expensive. There's only 1 million of them available. And in the United States, we're running out of them. They're actually very hesitant to assign new PLMN IDs. They often require that you have a Spectrum license. So you can't get one as a small network operator. So you can use the shared PLMN ID, but there's some other IDs that we have to manage for you. And you can get them from our website. It's really quite straightforward. If you don't run into a problem with collisions, collisions are bad. Collisions mean your network doesn't work and people get kicked off your network. So you can get these identifiers from us. It's really kind of irritating, but you can do it. You have to get one for your, if you're going to issue SIMs, you have got to get a number called an MC block number. And each one of those, you can issue 100,000 SIMs to devices. So we try to keep the administrative headache as low as possible, but you do have to get identifiers from us. You can just get them from our website. It's really not that big a deal. If you're really interested in this, there's a webinar online. We'll be doing a white paper on this. Get these IDs. It applies both at LTE and 5G. 5G, everything has a slightly different name and a slightly different bit length because they can't ever leave anything well enough alone. So there are stuff in 5G, and release 16 of the 5G specifications added support for shared PLMN IDs. So in theory, in release 16, you're not going to have to worry about getting identifiers. But for now, if you're doing 5G or at least 15 or LTE, you need to get these identifiers. The other big thing is the core network. If you've done Wi-Fi deployments and you're used to that, people get really scared when you hear you've got to set up this core network. And they have all these wonderful diagrams of all these network functions, and oh God, this is a nightmare to set up. And we have to deal with all these different management functions and S2 connections and diameter connections and all this, and it's a real pain in the neck. It's actually not that hard. It's purely software. There are open source solutions that are available. It doesn't require a lot of hardware. I've seen an entire core network for LTE running on the Raspberry Pi device. This is not throwing big iron at this problem. You can run it in the cloud. There are multiple companies that sell it as a service. You can go to buy cells that have a EPC as a service, so many odd base stations, and you pay them a fee.
Are these online or these slides that you're showing?
I'll post
available.
Yeah, I'll make them available. I'll be posting these, but yeah, there's a bunch of open source solutions out there, and you can do them back locally. You can do your authentication online or in the cloud or whatever. It's really not that hard. If you've had to set up a Wi-Fi network, it's not much harder.
What's your experience with Facebook? Has, what is it? I forget what they're calling theirs. Started with an M, and it's not metaverse, but there's some open source for that they're pushing.
I don't know. I don't know their specific one. But there's the open core. There's a bunch of different open core projects. So, Nick versus Networking, if you've ever, that's a wonderful site. He's got a listing of a bunch of the projects there. The Open EPC project that Google hosts. Facebook has one that you're interested to see. I'll have to check that out. But basically, it's not actually as hard as people think. So, and you also have to issue SIMs. That's the other big thing people aren't used to, except they're used to them on their phones, and chippy card things. You can get those made yourself. There are companies that will issue them for you. You can go online and order a block of these. It's not a problem. Or you can issue SIMs by QR code. There are companies that do this service. It's really nice. I think it's great. Resources. I'm running out of time here now. So We do have a bunch of resources on the OnGo site, listing of various service providers, all the stuff you can do yourself and at your home to play what you want to do, but if you do this office or whatever, there are a bunch of different companies that will do this as a solution. We have listings of certified devices, we have a certification program. We have all sorts of white papers and webinars and deployment guides that cover all this, where most of this stuff came from. We have a big one on security coming soon, fire management, roaming, all that stuff, yada, yada, yada. There's some new stuff that's coming. As mentioned, there is discussion about adding additional frequency bands to these dynamically allocated spectrum. Those discussions are ongoing and early, but it looks like that's going to happen. They're going to add more frequency to this. Still in the US, there are some explorations in like the EU of doing something similar in the EU. We have defined something for geofencing, so you can make it so that the phones can find the networks they're in based off physical location. But in general, what we have done in the OnGo Alliance is we try not to touch the phone at all or that interface. So while we're doing all this stuff, it's all on the back end side, like the code systems management. So that's all coming soon. And there's also discussion right now of getting rid of that whole environmental sensing capability because it's a real pain in the neck monitoring where all the aircraft carriers are. And so they're trying to get rid of that. But that's something going on at like the FCC level. So that's that. If you have any questions, you can always go to our website, and I'm here to answer questions. And that's part of my job is to help answer questions people have, and I have questions for him. So I'll be asking those questions too. But anyway, that's OnGo in a nutshell. Sort of. Are there any questions here? Right.